Hey guys, welcome back once again. In today's topic, we're going to discuss about a very important concept called photoelectric effect. This is basically a problematic concept. They usually ask you questions on solving. The relevant formulas will be given to you, so you have to make use of it and you have to solve the questions related to it. Before going to understand concepts of how the data has given and how it is working, I suggest you guys to go through the concept called photoelectric effect. So here I'm not going to discuss those. I'm just solving the questions relevant to it. You should have a clear understanding of what does the photoelectric effect means. All right. So let's start with the first question here. So let's go before starting the question, let me show you an important thing. Whatever the formula related to this topic has been given, there are two formulas needed and it is available in the data sheet. So energy formula is given by E is equals to Hc divided by lambda, where E is representing energy. H is called Planck's constant, and that's the constant value which is given to us. Planck's constant. C represents speed of light, and this V represent the frequency. Frequency sometime can also represent it with the notation F. F or V, it means the same, okay? That is frequency, and this symbol is lambda, and this is represents the wavelength. Any question asking about this concept, they use the term among these and how they are related with each other. I'll be using the formula and solving it accordingly. See, E is equals to Hc by lambda, and we can also say that V, which is frequency, is equal to C by lambda. If you replace C by lambda with frequency, this equation is also equal to E is equals to H into frequency, okay, where H is the Planck's constant, V is the frequency we are talking about. Either I use it in this way when the question asks me to solve for frequency or energy relation. I use this way if the question asks me to solve for wavelength and energy relation. If the question asks me to calculate the frequency, if wavelength is given, or wavelength if the frequency has given, I use it. Okay. So accordingly, let's see. First question says here, a hypothetical wave has 7.2 joule of energy. Energy has given. What is its hypothetical approximate frequency? Energy has given and asking you to calculate the frequency. Now, which formula should I use? The formula is energy is equals to H into frequency, which I wrote. So we are asked to solve for frequency. It's use this. Okay. So from this one, rearrange it. So frequency is equal to energy by what? So Planck's constant. So energy value has given, that is 7.2 joule. And what is the value of Planck's constant H? The value will be given to us in the data sheet. Let me show you. This is the value of a Planck's constant. This data sheet is provided to you in exam, whose value is 6.626 into 10 to the power negative 34 joule second. So the unit of energy is joule. So here it is joule second. That's why we have to use Planck constant value with the energy unit as joule. Okay. This is the speed of the light. That is, speed of the light is 2.998 into 10 to the power 8 meter per second. So data has given. So here I just need a Planck's constant value, that is 6.626 into 10 to the power negative 34. If you put it in the calculator, you'll be getting the value here it as 1.08 into 10 to the power 34 per second. Frequency is measured in terms of per seconds, or it can also be measured in terms of hertz. Whichever the unit available, it's fine because they have given us. So I'll be getting here it as 1.08 into 10 to the power 34 per second is the frequency of the light which is talking about here. Let's talk about question number 2 here. A photon with 5.1 electron volt of energy will eject an electron from a piece of gold. What wavelength does light with this energy have? What question asking you? Energy has been given and asking a question about the wavelength. So they're asking you about the wavelength. What would be the wavelength of this light? Another important thing what you can observe is this time energy has given in terms of electron volt, because the energy delivered by photon is very small, so that's why it measured generally in electron volt. But before using in the formula, you should be converting energy in terms of joules, because Planck's constant has given in joules. So how do you convert energy in terms of joules? You should multiply the electron volt value, that is 5.1, multiply with value of this 1.6 into 10 to the power negative 90. So this will be converted into joule. So if you just multiply this value, what are you gonna get? 5.1, 5.1 times 1.6, that gives us 8.16 into 10 to the power negative 19 joule. So that is how you convert. Now use the formula, which one? Relation between the energy and the wavelength. So we have to use this first formula. E is equals to h c by lambda and rearrange it. Equation is E is equals to h c by wavelength. So if you rearrange it in terms of wavelength, what do you get? So wavelength is equals to Planck's constant times speed of the light divided by energy. It's a math. I'm just doing cross multiplication and solving it. Now just do the substitution. What is the Planck's constant? 6.626, as I told, it's given, into 10 to the power negative 34 joule second. I'm not writing the units. Let me just put the value. Speed of the light is 2.998 into 10 to the power 8, divided by what is the energy we got? Energy this 8.16 into 10 to the power negative 19. So if you put it all this data carefully in the calculator, you'll be getting it as 2.427 into 10 to the power negative 7 meter. This is the wavelength you get. So 2.427 into 10 to the power negative 7 meter, or it could also be represented in micrometer, nanometer. You can make use of unit conversion. So that's how the question has asked. Question number 3 here is, a photon delivered 7.89 electron volt of energy to a single gold electron. Means energy given by the photon to an electron of a gold atom they're talking about. If work function of gold is 2.3 electron volt, what is the kinetic energy of ejected electron? So they're asking you something term, work function, kinetic energy, and so on. If you study the concept of photoelectric effect, you will be understanding. So what they're trying to say, let me just give you simple hint here. So suppose this is the gold metal and here we have a gold atom. So to remove this electron from the gold atom, whatever the energy delivered by a photon, photon is delivering energy, and after getting that energy, the electron should jump off the metal surface. That is called the photoelectric effect. But it will not always jump out of it. There is a certain condition. So electron should need a minimum amount of energy to jump out of. That minimum amount of energy needed, it's called work function. So work function is the minimum energy needed for electron to jump out of the metal surface. Okay. And whatever the extra energy delivered, it will be converted into the kinetic energy. So I can say now the supplied energy by the photon is equal to work function plus the kinetic energy. This is the symbol for work function. Okay. This is called work function. And Ke is the symbol for kinetic energy, or I can simply say, yeah, kinetic energy, or I can simply write it as Ke. Now, this has given and work function has given. They're asking you to find kinetic energy in terms of electron volt. As the kinetic energy is asking in the same unit, no need of converting that electron volt into joule. So how do you solve for kinetic energy? Simply by rearranging the equation. So kinetic energy is equals to supplied energy minus work function. So supplied energy is how much? 7.89 electron volt minus work function is 2.3. So what are you gonna get? 7.89 minus 2.3, that gives us 5.59 electron volt. So I should get the kinetic energy is 5.59, means out of 7.89, 2.3 is used for the electron just to escape from the metal. Remaining energy is used to speed up its ejection. So that is what the kinetic energy is. Okay, so that's how the questions can be asked. By the way, this formula will not be given to you. It's better to know work function, kinetic energy and all. Please memorize it. They do ask you question on based on this as well. Let's work on question number 4 here. What is the threshold frequency F0 of mercury if its work function is 7.14 electron volt? And they also given us the unit conversion. 1 electron volt equal to this is, whenever it is needed, the conversion unit will be given. So now what is the threshold frequency then? See, work function, whatever we have discussed in the previous question, is the minimum energy needed by the needed for the electron to eject, and that minimum energy is equal to the Planck's constant times the threshold frequency. Threshold frequency is again a light which is falling on the metal surface should have a minimum frequency of this. If the frequency of the light lesser than the threshold one, electron will not be ejected because energy is directly proportional to the frequency. Greater the frequency, higher the value of energy, because H is a constant. So we are asked us, if the work function has given, they're asking you what is the minimum frequency. So minimum frequency or threshold frequency means the same. Rearrange it. Threshold frequency is equals to work function divided by Planck's constant. Work function is again an energy, okay? So it's nothing but energy, but it is the minimum energy required. That's why it is named differently. So while converting that energy in terms of joule, you can see that they have given us in terms of electron volt. You should convert into joule and then substitute. So how do we gonna do? Let me just substitute here. 7.14 is the energy in terms of electron volt. To convert into joule, you should multiply by this 1.60 into 10 to the power negative 19. Now this is the work function in terms of joule. After multiplying that, divided by Planck's constant. What is the value? 6.626 into 10 to the power minus 34. By the way, I have remembered this value, but no need of memorizing and getting panicked, okay? This data will be given to you. So you can just use it. When you substitute this carefully in the calculator, you will be getting it as 1.72 into 10 to the power 15 hertz. As this time they gave us in terms of unit hertz, so we can say 1.72 into 10 to the power 15 hertz is the minimum frequency of the photon or the light should have. If the light which is falling on the metal with the frequency lesser than this, electron will not eject it. So that's what the work function means. Now let's go with the last question here. Question number 5. How much energy does a light with a wavelength of 729 nanometer have? This time wavelength has given and asking you the energy. So by the way, what is the formula given to us? Energy is equals to Planck's constant times speed of the light divided by wavelength. This is the formula which is given to us. I'm just using it, this is. So substitute it. So as they have given, the wavelength is 729 nanometer. So nanometer meaning this value multiplied with 10 to the power negative 9. So 729 into 10 to the power negative 9 meter. That's we do the unit from nanometer to meter because SI unit for length is meter. So you do conversions. Planck's constant again 6.626 into 10 to the power negative 34. Speed of the light is what? 2.998 into 10 to the power 8 divided by Wavelength we got it as 729 into 10 to the power negative 9. Put it carefully in the calculator. You'll be getting the energy as 2.72 into 10 to the power negative 19 joule, which is also same as, okay, this is in terms of joules. If they are asking you to convert in terms of electron volt, you should be dividing it by 1.6 into 10 to the power negative 19 if needed. But here they asked us energy in terms of joule itself. Fine. 2.72 into 10 to the power negative 19 joule. So that's all the calculation type of questions what we expected on photoelectric effect. So I hope this will help you to understand and solve the questions relevantly. That's it for today's session. Thank you so much, and please do like, share and subscribe to my channel so that when I upload a videos, you will be notified. All right. All the best. Thank you.